Hi, this is Makoto, and welcome to the joy of d3.js. Today, I'm going to talk about transitions. So, transition is one of the most exciting part about d3.js. I'll go back to Hans Rosling talk all at the OK Fest. So he says it's very difficult to do with software with static feature. Visualization, which has in SAS and other software, it's good to explore, but when you communicate, you have to build yourself. That's what he mentioned in this OK Fest. And that's so true, not just in statistical libraries, but also other graphing and charting libraries. Many charting libraries are static, so what you end up is re-rendering chart with new data. That will work, but sometimes animating the difference of the data from one point to another help viewers to understand what has changed. Overusing animation is not good, but if you use it in the right occasion, it will enrich your data visualization a lot. There are two topics I cover today. One is D3 API about transition, and another is a D3 patterns called join. So let's first start with very easy example with this commit. Okay, start. So now you should be able to see that the circle is moved a bit to right bottom. Let's try again. Yeah. Let's see the commit difference to see what has been changed. So it's actually just 3 lines. And it has 2 new function calls, transition and duration. If you look into D3 documentation, it says as follows. So starts are transition for the current selection. Transitions behave much like selections, except operations animate smoothly over time, rather than applying instantaneously. Okay, and the duration is probably easy to guess. It just specifies the length of period it transitions for. If you don't specify, it sets to the default of 250 milliseconds. I think it was easy so far. So this is the whole code now. And this is a bit it's being added. But in a real situation, you just don't transition from like 10 pixel to the right button. What you really want is to transition from one data to another. So let's check out the next commit. Next commit. Okay. So next one is this one. This one has slightly different animation. Let's find that. So rather than moving from one point to another, the circle eased in. Let's try again. Yeah. So let's see the commit diff of this one. There are several changes. So first, there are 2 datasets. So rather than having data, it now has data 1 and data 2. Second, I put the rendering code into a function called chart. So this one, which takes the data as an argument. Third, data function is taking 2 arguments rather than 1. The second argument is a function which returns ID. This one. Oops, this one. Fourth, I separated out enter and transition into 2 parts. So this one. And added different radius size. So this is 0 and this is 5. And fifth, I have a circle.exit code. And lastly, I am calling the chart with date 1, and this is actually the old code changed, right? So 2 datasets and the data with function and gap and chart as a function and exit and calling that chart. Okay. You can also see the comments suggesting to call it with data 2. So let's try it out. So here, chart, I'll make it a bit bigger. Chart data 2. Yeah. I'll try with date 1 now. It goes back like that. So you can see that new circle appears, existing circle moves, and one circle disappears. And this is one of the most critical concepts you have to understand in d3.js. It's either called enter, update, exit model or simply joins. So Mike wrote a blog post called Thinking with Joins, and I recommend you read the article at least 3 times, but I will try to explain here. In his blog, there are 2 circles. Treat each circle as one dataset. So imagine you call the char function for the first time. It goes into the blue circle phase, and the call function chaining enter and update. In our code, let's go back to our code. So this is what it's calling enter, and this is what it's calling update. One thing you have to be careful is that there's no function called update. It's just the element that is specified. So whatever you specify in this one becomes update. The CX and CY on these 2, they're exactly the same this time, so it does not change. However, R is changed from 0 to 5. Hence, it animates like eSIM in this example. Right? So first 0 is 0. And then when it goes to update, it moves to 5. Okay. Now you can call the char function with different dataset. So date 2. And go back to this model. If the data is brand new data, it's same as a blue circle. It runs enter and update. However, if the data already exists, then that's equivalent to the intersection between red circle and the blue circle, only executing update. If second dataset did not include the same dataset as the first one, then exit function is called. Yeah. Do you follow me so far? If you have followed me well, then you must have one question in mind. So how do you identify the data is new or old? That's a great question. By default, d3.js takes index of array as an ID. That means if all data have 2 rows and new data has 3 rows, the first and the second rows are existing data, and the only third row becomes the new data. However, you can customize the behavior by passing the second argument on the function. In our example, we passed a did here. Hence, it recognizes that ID1 is all data. So this one, it doesn't exist here, so it's all data being removed here. And 2, they exist in both. Hence, changing CX and CY position moved. And the ID3 is new data where radius is changed, this one. It will take a while to digest this concept, so I prepared 2 playgrounds. The first one is the same code as our commit in tributary, just adding button to chart with new data. So if you click this, it moves from one. If you click this one, it moves to the other. Okay. The second one is in blocks.org, dynamically generating new dataset and updating with set interval. You can easily replace it to take new data via WebSocket or Ajax call to make your data visualization real time. Okay, that's it for today, and thank you for watching.